Okay, so here are the solutions for using the law of sines. So the first problem shows you the triangle. The next ones after that don't show you the triangle. So what we have is an obtuse triangle because this angle is greater than 90 degrees. And if you look in your book, you've got in terms of obtuse triangles, you have the situation where there's one solution as long as this distance is greater, or actually, that these distances are less than this distance. And from the drawing, you see that the triangle does actually exist. So you got the law of sines, which says the sine of the angle, sine of angle A divided by the length of side A is equal to the sine of angle B divided by the length of side B, and that's equal to the sine of angle C divided by length C. And you also have that A plus B plus C equals 180 degrees. So we can determine angle A just by taking, so angle A, the measure of angle A is 180 minus B minus C. So that's 180 minus 40 minus 105. So that's 180 minus 145, which is going to be 35 degrees. So we know that angle is 35 degrees. I'm just double checking on my calculator. 180 minus 40 minus 105. Now I'm wondering whether that's a 46 or a 40. It's 40. Okay, so that's 40. Let me just fix that so that it is clear. Okay. Now, as far as the other sides, we can use the ratio, so we know that the sine of C over C is equal to the sine of B over B. So we don't know side B and we don't know side A. So if you take this ratio, which is the last two terms in the law of sines, and solve for B, what you would do is you take this B, which is in the denominator, move it to the left-hand side, which means it goes to the numerator. And then the sine of B stays put here. The sine of C becomes from the numerator down to the denominator. And this C, which is in the denominator, gets moved to the numerator. So we get the sine of B, which is 40 degrees, divided by the sine of C, which is 105 degrees. And we multiply by the length of side C, which is 20. And make sure our calculator's in degrees. So we get the sine of 40 divided by the sine of 105 times 20. So you get 13.3. And that makes sense, because this being 105 degrees, this should be the longest side. And it is. Compared to these two sides, we still need to find A. And you can end up with the same situation here. You're going to end up with the sine of A over A is equal to the sine of C over C. And we could use either one of them now. We could use either B or C because we know that. But so we want to solve for the length of side A. That's going to go to the numerator. And so we get the sine of C divided by the sine of A times C. So if we solve these proportions for A, this goes to the numerator. So it's there. Solve for A. This goes up. This goes down. So I've actually got those the wrong way around here. think I do actually. Yeah, I've got those wrong. I'm glad I checked it. So it's the sine of A divided by the sine of C. The side, if you have two common things in the same side, meaning side C, an angle C, have the same letter, then they should be in opposite. One should be in the numerator and one should be in the denominator. Okay, so now we can plug those in, what we know. So side A is the sine of A, which is, we figured out from A was 35 degrees, divided by the sine of 105 degrees, times the length of side C, which is still 20. So we get the sine of 35 divided by the sine of 105 times 20. So we get 11.9. And again, that makes sense because, you know, here we have 35 degrees, here we have 40 degrees, so the one that has a higher angle should have the longer side. So those are all the unknowns for this problem. Okay, the next bunch are just like this one, except we haven't drawn them. So, you know, what we could do is try to sketch out what's going on here, just to have some idea of what might be the situation. And if you look at the different cases, you know, what we have is we have an acute angle. It's about 60 degrees. So this angle is 60. And it's saying that the side opposite, which is here, this is A, so this is angle A. This is 9. And then we have side C, but what we can do is we can call this angle C. So this is side C, just so it fits the diagram, the ambiguous case, because we're given two sides and an angle. So what we have is that in this case C is greater than A. This side is greater than A. So I think that what that means is that there are possibly two cases, possibly two solutions. Possibly. I guess one way is you got to figure out what the height of this part is. So you can do that. This is the height. And you can find the height by using the right triangle, because the height is a right triangle, using this right triangle. And so what we would say is that the sine of 60 degrees is equal to h over c, h being the height, c being this side c. So if we solve for c, it's going to be h divided by the sine of 60 degrees. Actually, what I'm trying to do is solve for, and we know c is 10 because that's given in the problem. Okay, so if we solve for h is equal to c times the sine of 60 degrees. So c is 10, sine of 60 degrees. We plug that in our calculator. So 10 times the sine of 60 is 8.66. So that's h. And so let's rank these. So it says if so h is this way, then we have A, which is 9, and then we have C, which is 10. If this is the case, which it is, there are actually two solutions. So in the diagram, this is H is less than A is less than B, but it just happens they use C in this case, so you gotta kind of transform the two things. So what happens is you can have a solution that looks like that, or you can have a solution that kind of goes this way. So this thing could swing and go here, or it can swing down this way and intersect it before it runs into A. So the question is, what are the two solutions? How do you figure out what the two solutions are? So we still have the law of sine still applies. You have A over the sine. I always get them the wrong direction here. You have the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. So what we have A angle A, and we have side A. So let's we'll use this one, and we'll use this one to find angle C. But there are two solutions for C. There's one that's an acute angle, one that's an obtuse angle. So let's just set it up here. So you get the sine of A over A is equal to the sine of C over C. So to find angle C, you got to find the sine of angle C. So we solve for sine of angle C. All we have to do is get this length C to the other side. So it's going to go from the denominator to the numerator. So you get that. So the sine of C is equal to the sine of A, which is given as, is that 50 degrees? 60 degrees. Sine of 60 times C, which is 10, divided by A, which is 9. So the sine of C equals the sine of 60 times 10 divided by 9. So that's 0.962. So C is going to be the inverse sine of 0.962. What that'll do is it'll give me this solution. So I'm going to take the inverse sine of 0.9662. So that's 74.2 degrees. So that's one solution. Now the other solution, if you think about the unit circle, is another angle that has a sine of 0.962 is right over here, and it's going to be symmetric around the positive y-axis. So if this is 74.2 degrees and this is 90 degrees, then the difference here is you take 90 minus 74.2, so you get 15.8 degrees, and then you take that number. So another answer is going to be 90, instead of 90 minus 15.8, it's going to be 9 plus 15.8 degrees. 90 plus 15.8 is 105.8 degrees. So that's the angle. That's angle C. This is angle C. And if you actually take the sine, if you use your calculator to find the sine of 105.8 degrees, you should get 0.962. So the sine of 105.8 is 0.962. So it's true. Okay, so that's how you get the two solutions. So so once you have those two solutions, you've got this angle B and this side B. So you can get the corresponding third angle by using the sum of the angles equals 180. So solution number one, we had that angle A was 60 degrees. and angle C was 74.2, and angle B is therefore 180 minus 60 minus 74.2. 180 minus 60 minus 74.2, which is 45.8 degrees. And for solution 2, again, you've got A is equal to 60 degrees, but now angle C is the other solution, which is 105.8 degrees. So angle B is 180 minus 60 minus 105.8 degrees, which is 14.2 degrees. So once you've got those two angles solutions for B, then you can use the law of sines again. So we have the sine of A over the length of side A. So this is solution 1. So you get sine of A over A is equal to the sine of B over B. If we want to solve for the length of side B, this comes to the numerator. Sine of A goes to the denominator, and length A goes to the numerator. So you get B is equal to the sine of angle B, which is 45.8 degrees divided by the sine of 60 degrees times A, which is the length of side A going back here, is 9. So the sine of 45.8 divided by the sine of 60 times 9, you get 7.45. And the second solution, same thing. B is equal to the sine of B times A divided by the sine of A. But now we use angle B from the second solution. So we get B is equal to the sine of 14.2 degrees divided by the sine of 60 degrees times 9. And I get 2.5. So let's go back and look at these two solutions. So B is the side that's this side. So you can see here with this solution, this length here is 7.45. And when it goes this direction, you just get this little short length. And I was just looking at the solutions, at least as far as the even solutions, that's the only one that has two solutions. So we'll see what happens with the next one. So this is number 3. So again, we'll draw a figure here. So what we have is this pretty small angle, 24 degrees. And we have an angle C, which would be the second angle, which is going to be 55 degrees. So it's going to be something like that, approximately. So let's say this is angle A. We'll call this angle C. And it looks like this angle is going to be, well, it is going to be greater than 90 degrees. So there's only one solution associated with this. So this is angle C, which is 55 degrees. This is angle B. And side C is this one. So C is equal to 2.7. This is side B. This is side A. And as far as whether there is a solution or not, before we go actually do the problem, again, if you go back to the ambiguous case, if this angle is obtuse, what has to happen is that this length has to be well, in this case, we're only given one length. So because these two angles are given and this length's given, we know there is a solution. And that because this angle is obtuse, there's only one solution. So we really don't have to think too hard about the solutions here. So we just have to figure out what angle B is, which we can do because we have two of the angles. So the measure of angle B is just going to be 180 minus the other two angles, 24 and 55. And that should be, it's very close to 90. No, it's close to it. It's about 100. So you take 100 minus 24 minus 55, and you get 101 degrees. So that's greater than 90. So it is an obtuse solution. Okay, now the rest of it, we just have to apply the law of sines to find the two unknown lengths, because we have all the angles now. So we know what the sine of the angles are. We can figure those out. And we have the last part. We have angle C. So we have the sine of 55 degrees divided by 2.7. And here we have the sine of angle B, which is going to be 101 degrees divided by the length of side B, and the sine of 24 degrees divided by the length of side A. So we can solve for both A and B, solve B by setting these equal to each other, and then find A by setting those two equal to each other. So if we take these two and we solve for B, B will go here, it will go to the numerator. So there you go. And then we move everything else to the left-hand side, and then we can flip them around. So we'll have the sine of 101 degrees, divide by the sine of 55 degrees, and move this up. So this comes down, this goes up. So that's times 2.7. So we get the sine of 101 divided by the sine of 55 times 2.7. And I get 3.2. And then here to find side A, we'll set these two equal to each other and we solve for A. Same kind of thing. We're going to keep the sine of 24 degrees here. That'll come down. We'll divide by the sine of 55 degrees. And we'll multiply by 2.7 again. So the sine of 24 divided by the sine of 55 times 2.7 gives me the length of side A is 1.3. So I've got 3.2. And okay, so that's correct. Okay, let's move on to number 4. So let's kind of draw a rough sketch of this thing. So you got this big angle, so it's going to be a really flat triangle. I mean, the sum of the other two angles has to add up to 35 degrees, so it's going to be really flat like this. So this angle we're going to call angle C is 145 degrees. Let's call this angle B, and we'll call this angle A. So this is side B. So side B is 4. Side C is 14. Side A we don't know. So as long as C is greater than B, then we're going to have a solution. And this number is going to be, since this one's 4, this one's 14, this one's going to have to be 13, something like that. It has to be less than that length, but it's probably much more skewed this direction. So that's my guess. And again, if you go back and look at the requirements, there's either going to be one solution or no solutions. And the only requirement is that this is greater than that, which obviously it is. So now all we have to do is use the law of sines again, which says the sine of angle A divided by the length of side A is equal to the sine of angle B divided by the length of side B is equal to the sine of angle C over C, the length of side C. Now, because we have two sides and one angle, we can't immediately use the sum of the angles equals 180. So we're going to have to use this to find one of the angles, and then once we have that second angle, we can calculate the third angle. Once we have the third angle, we can calculate the third side. So what do we have here? We have side C and angle C, so that's obviously going to be what we're going to use here. And we have side B, so we should be able to find angle B. Once we get angle B, we can find angle A, and once we have angle A, we can find side A. So that's kind of the process. So let's use these two. So we get the sine of angle B, which we don't know, divided by length B, which is 4. In this case, I'm not going to solve for it first. I'm going to plug the numbers in. So you get the sine of angle B over 4 is equal to the sine of 145 degrees divided by 14. So if you solve for the sine of B, it's going to be equal to the sine of 145 times 4 divided by 14. So what do we get? Sine of 145 times 4 divided by 14. So I get the sine of B equals 0.164. And you can take the inverse sine of that. Inverse sine of 0.164. And you get 9.4 degrees. So this is 9.4 degrees. So C is going to be equal to 180, not C, A is the one I don't know. So angle A is going to be equal to 180 minus 145 minus 9.4. So that's 25.6 degrees. So that's it, 25.6 degrees. And then you can use either one of these because we know both the angle and the length for B and C. So we just need to. So let's use the first one here. The sine of A over A is equal to the sine of C over C. So let's plug them in. Again, I'm not going to do it algebraically. So we have the sine of 25.6 degrees divided by the unknown length A is equal to the sine of 145 divided by 14. So if you solve for A, you'll have the sine of 25.6. So this goes up to the numerator, this comes down to the denominator, and you multiply by 14. Now, theoretically, you could plug these into your calculator and get numbers and have a ratio and solve for it. So that's the least elegant, but I guess for some people maybe the only way that they can figure this out. So we get 10.5. So this is 10.5, and it makes sense because I said, you know, this being 4, this had to be close. I said 13, but it's actually not that. But if you take 10.5 and add 4, you get 14.5, which is greater than, you know, so that makes sense because if you go between 2 points in a straight line, if you don't go a straight line, so if you go up here and then back down, that the sum of those two should be greater. Shortest distance between two points is a straight line. Okay, so that one is correct. And one more here. So let's think about what's going on. It's close to a right triangle. So let's just draw a right triangle, slightly less than a right triangle. So I'm going to draw it kind of like that. A right triangle would be there. Okay, so that's 85 degrees, and that is angle A. Then opposite, you've got side A. So that was side A, that's 35. And this side here is 50. If this is angle C. And this would be angle B, and this would be side B. So the question is, is there more than one solution? Do we have to worry about more than one solution? So the way you do that is you would calculate this height. Could you calculate the height that direction or not? I'm not sure if you could, because we don't. I think you'd have to orient this triangle differently. You'd have to think about what you'd have to do is say this is 35, and we would switch these angles. So this is this would be angle C and B. So we'll switch those around. So this is we'll call that C. We'll call that B, and I think because this is side, angle side, I don't think it's an ambiguous case. Yeah. So in this case, it's not an ambiguous case. So I think there's just one solution. Okay, let's make sure I got this right here. Oh, that's not, well, yeah, that's not. So this opposite side has to be 35. So this is 35. The question is, you know, if this were 50. See, what I can see happening is that the side is long enough that if this were 35, that it would make it so that if this thing were to sweep out an arc, that it's going to not intersect this axis. And so let's go back and look at this. Let's look at the pictures. And if there are no solutions, well, it says if these are so what we have to do is we have to calculate this height and compare this length. If this length is less than the height, then there are no solutions. So this is the first case. And if A is less than H, there are none. So the H again we'd use a right triangle where this is the hypotenuse and this is the opposite. That's what we're trying to figure out. So we'd say that the sine, using right triangle geometry, the sine of 85 degrees is equal to the opposite, which is H over 50, which is the hypotenuse. So H is equal to 50 times the sine of 85 degrees. So 50 times the sine of 85 is 49.8 degrees, or not degrees, length. And because since this is A, so we'd say since A is less than H, or in this case 35 is less than 49.8, there are no solutions. So I'm going to check this one here. Okay, so I have checked out. I actually wrote the problem down wrong, but that's okay. They had C as 85 degrees. In that case, there is a solution, but in this case, there is no solution. So having gone through these, I'm going through the homework kind of in between finishing off the notes. You know, this whole thought process of figuring out whether you have solutions or not is something that I think you're going to have problems with. So I'm going to try to explain that more in the notes, and hopefully you'll understand this better. Because let's look at the case. What I'm going to do is I'm going to add another problem here. 6. Let's say C equals 85 degrees, and A equals 35, and C equals 50. So let's see what that one looks like. This one actually does have solutions. So you've got this angle 85 degrees. You've got some opposite side, which is in this case side C is 50, and A, we'll call this side here A is equal to 35. And the question is if C, if this height is, well, actually this fits scenario number 3 on your diagram. If you look in your book, if this number is greater than this number, then there's only one solution. That's because if I took this length side and I rotated it around, it's not going to intersect this here. It would rotate all the way around here and run into this horizontal line, but then this angle 85 degrees would no longer be an internal angle. So this is scenario 3 if you look in the book. So it means there's only one solution, and hence the procedure is reasonably simple. So again, you'd have the sine of A over A equals the sine of B over B, sine of C over C, and because I'm given one angle and two sides, I can't find the other two angles until I use the law of sines to find that. And you can see I have C, so I'm going to use these two parts, set those equal to each other. So I'll have the sine of A, which is unknown, divided by the length of side A, which is 35. So this is actually angle C. This is angle A. This is angle B up here. This would be side B. This would be side A. So we get the sine of A over 35 equals the sine of C, which is 85 degrees. So let me go plug those in. Oh, well, yeah. 85 degrees divided by 50. So if we algebraically solve for the sine of A, that's going to be equal to the sine of 85 degrees times 35 over 50. Sine of 85 times 35 divided by 50. So I get the sine of A is equal to 0.697, or A is equal to the inverse sine of 0.697. So that's 44.2 degrees. Then I can figure out angle B. It's 180 minus 85 minus 44.2. And that's 50.8. And because 42 and 50 are pretty close to each other, these lengths should be comparable. So the length of side B should be close to 35. So now what we do is we could use either one of these. We're going to take this and we're going to set it equal to, we'll just set it equal to that one. So we have the sine of B. B is 50.8 divided by the length of B, which is what we're trying to figure out. That's equal to the sine of C, which was 85 degrees, divided by the length of C, which was 50. So if we solve for B, we'll get the sine of 50.8 divided by the sine of 85. And so we're trying to solve for B. So this is times 50. Okay, so the sine of 50.8 divided by the sine of 85 times 50 is going to be 38.9. So that matches up with what I said. I said these two lengths should be pretty close to the same thing. And because 50.8 is greater than whatever the angle is here, what's the other angle? 44.2. So because that's greater than that, B should be greater than A, which it is. Okay, so that's those problems. So let's move on to the next one. 2 in this group. It says find a value for B, which is the length of side B, such that the triangle has one solution, two solutions, and no solutions. What if that's the angle B? Oh, this is actually the wrong instructions. So let me fix the instructions here. So use the information to solve, if possible, the triangle. If two solutions exist, find both. Okay. So it's the same kind of deal as we've been doing before. Let's just sketch this and see if we can figure out what it looks like. So I'm going to draw the triangle like this. This is 58 degrees. Let's call this length B, 12.8 degree, 12.8, and then we have another side A, which is going to be 11. So there's some side, something like this, and this is side A, which is 11.4. And the question is, are we going to get two solutions? Well, what you have to do is you have to figure out what this height is, and then see how they rank. Now we could actually have no solutions. If we took this side and we rotated it around at 11.4, and if that is shorter than the height, then you get 0 solutions. But I think we're going to get at least one solution. So let's compare these lengths. And so H, we again use the right triangle geometry because this is a right angle. So what we say is that the sine of 58 degrees is equal to H over 12.8, or H is equal to 12.8 times the sine of 58 degrees. So I get 10.86. So now let's go back to look at this situation. And if H is the smallest one, which it looks like it is, so we've got H, I'm going to write it under here, is 10.86. And if that is less than A, which is 11.4, which is less than B, which is 12.8. So we do have this situation where this height, so when this thing rotates, because this height is less than 11.4, it is going to hit, it's going to hit here, and then it'll come back around, and because 11.4 is less than 12.8, it's going to still have a triangle with 58 degrees. If A were greater than 11.4, what it would do is it would swing around here. If A were greater than 12.8, then it would come around here and they would coincide, and then it would have to swing even further, and this interior angle would become an exterior angle. So that's kind of this area. So there are two solutions. So we need to find both solutions. So we're going to do the first solution. We're going to do this one because that's the easy one. It'll be all angles, I think, that are less than 90 degrees. It's going to be an obtuse triangle. So let's again, this is angle A. This is side B. So this would be angle B here. This angle B. This would be C, angle C. This would be side C. So what we can do is we can use the law of sine. Sine of angle A over side A is equal to the sine of angle B over side B. Sine of angle C over side C. So because we know these two parts, the angle and the side length, we're going to first solve for angle B, where the angle is an obtuse or an acute angle. So we're going to use these two to solve for angle B. Once we have angle B, we can find angle C. Once we have angle C, we can find side C. So that'll be solution 1. So let's go ahead and do it. So we get the sine of A, 58 degrees, divided by the length of side A, which is 11.4. And that's equal to the sine of angle B, which we don't know, divided by length B. So if you solve for length B, actually we're going to solve for the sine of B. So we get the sine of B is equal to the sine of 58 degrees, and we're going to bring that up here. So I need to go ahead and put side B length in there. I already know what it is, 12.8. So this, to solve for the sine of B, we move that up to the top, so we get 12.8 divided by 11.4. Sine of 58 times 12.8 divided by 11.4. Sine of B is 0.952, and you take the inverse sine, and we get 72.2 degrees. Okay, so that's angle B. Therefore, angle C is going to be 180 minus angle A, which is 58, minus angle B, which is 72.2. So we get 180 minus 58 minus 72.2, and that's equal to 49.8. So you can see all these angles, 58, 72, and 49.8, they're all less than 90, so it's an acute triangle. And then once you know side C, or angle C, then we can use the law of sines using the first and the third ratio. And what we need to do is solve for side C. So again, I'm going to do this algebraically just to mix it up. So I get the sine of C divided by the sine of A times the length of A. So C is the sine of C, which is, just figured it out, 49.8 degrees divided by the sine of A, which is, A was 58 degrees, and A, length of side A was 11.4. So the sine of 49.8 divided by the sine of 58 times 11.4 is 10.3. So now we know everything. I'm just making sure everything makes sense. So this is the smallest angle of the three, so it should have the shortest length. This is 58 is the next one, which has the next length, and 72 degrees has 12.8. So that all makes sense as far as relative size is concerned. Okay, so that's solution one. Now solution two, it's the same kind of deal here. Is that the other solution? So I'm going to say solution two. To get solution two, what you do is what you have is, if you take 90 minus 72.2, you get 17.8. So my next solution is, instead of 90 minus 17.8, it's 19 plus 7.8. Which is 107.8 degrees. And if I take, what I can do to double check this is take the sine of 107.8 degrees, and it should be the same as I used here. There's two solutions. One solution is 72.2, the other one is hopefully going to be 107.8. So if I take the sine of 107.8, I get 0.952. So that's my other solution. So now I can find angle C. Still have 180 because the sum of the angles in triangle. I still have the same angle A, 58, but now I'm going to subtract 107.8 instead of 72.2. And I get 14.2 degrees. So that's angle C. And then I can use the law of sines same one I used previously, but now I have a different angle C. Before it was 49.8, now it's 14.2. So I'm going to plug the numbers in here. So I have the sine of 58 divided by 11 or 12.8. So what I used last time. I think I used the wrong number last time. Yeah, I don't think this is right. This should be 12. Side A. Yeah, no, that's right. 11.4. Okay, so let's go back here. So sine of 58 over 11.4. You get the sine of 14.2 divided by length C. So C is going to be equal to the sine of 14.2 divided by the sine of 58 degrees times 11.4. So I get 3.3. And again, that makes sense because what's happening is this thing is rotating around, and you're going to have one solution that looks like that, and the second solution is going to be kind of like that. And so you get this really short length for C. And that's also because this angle C, is really small, relatively speaking. So that from a order of magnitude standpoint, they make sense. But I'm going to pause it and check the answer. Okay, so that one is correct. Okay, so now we got another situation here. So let's kind of draw it out. This is number 8. And I'm thinking we have no solutions to this one. Just it's a gut feeling. So this is angle A, 76. So I'm drawing it close to 90, but less than 90. Then you have some opposite side. No, actually, I think there's one solution. So this is side B, 21. And then we have the opposite side, which is 34. So that's 34. So that's length A. This would be angle B right here. This would be angle C. This would be side C. So what you see is that this thing is pretty long, and so because this number is greater than that number, that's kind of the key thing, because this is greater than that. If this thing were to rotate around, it would get to here and it would be too long, and it would have to rotate all the way over here. And if it did that, then you'd have this 76 degrees would now become an external angle instead of an internal angle. So that's just my gut feeling. But let's go back to the different choices. And if you go to the third case, you've got angle A. And if A is greater than B, then there's one solution. So if there's kind of the three scenarios. If this number is greater than that number, then there's one solution. If this number is less than that number, then there's two cases. If it's shorter but not too short, then what will happen is you'll get a solution here, and you'll get another solution as this thing rotates around. If this is too short, then this thing would rotate around and would never touch this horizontal side. So I guess this is the easiest one, where B is greater than A. Now if it's the other way around, there's this scenario 4, which there could be two solutions, or scenario 1, which there are no solutions. So in this case, there's only one solution. And so that makes life easy. We just then say, okay, I can just write out the law of sines and figure out what I know and what I don't know. In this case, because I know two sides and one angle, I'm going to have to use the law of sines to find the unknown angle, and once I have the unknown angle, I can use the sum of the angles equals 180 degrees. So you can see with everything here, I don't know angle C and I don't know length C, so I'm not going to use that immediately. I'm going to use these two. And so I'm going to find angle B. So that means I'm going to use just the first two parts of this sets of ratios. In this case, I'm going to actually algebraically solve for the sine of B. So the sine of B is going to be equal to the sine of A. I'm going to move that up, the B up, and I'm going to move the A, leave the move, well, which one am I going? Yeah, I'm going to move this up. This was already in the denominator, this is already in the numerator. So I can go ahead and plug my numbers in. Now I got sine of 76 degrees times B, which is 21, divided by A, which is 34. Sine of 76 times 21 divided by 34 is the sine of B is equal to 0.6. And so B is the inverse sine of that number, 0.6. So I get 36.8 degrees. So that's angle B. Then I can find angle C because I have 2 out of 3 angles. So C is equal to 180 minus 76 minus 36.8. 180 minus 76 minus 36.8. And I get 67.2 degrees. Okay, so that's angle C. And then I can use this law of sines ratio again, but now that I know angle C, I can use this part. So if I algebraically solve for C, take this, move that up to the top, the sine of C stays on the right hand side, the sine of A goes down to the denominator, and this A goes up top. So we have the sine of C, which is C is 67.2 degrees divided by the sine of A, which is 76 degrees, times the length of side A, which is 34. So do that, sine of 67.2 divided by the sine of 76 times 34, 32.3. And again, you can kind of check your answer by just looking at the relative magnitude. So let's put the angles here in order of size. So you got 36.8, and then the next bigger one is 67.2, and the next bigger one is 76. So those are the three angles. This is angle C. This is angle B. This is angle A. Angle A. So the same thing should apply in terms of the lengths of the sides. So let's see what we got here. So A is 34, B is 21, and C is 32.3. And you see that they match up pretty close. And you can see that 67 is closer to 76 than 37, so you'd expect these two to be closer to each other and these to be more distant. So not only do the ranking indicate that we've got the right situation, but the relative magnitudes also have the same thing. Okay. Now the next one is to figure out the area of the triangle. So we've got these formulas, which says that the area is equal to 1/2 A times B times the sine of angle C, or 1/2 AC times the sine of B, and the third one is 1/2 BC times the sine of A. You just take two sides and then multiply by the sine of the other angle. So what we got to do is, in this case, we do have everything we need. We don't have to, we just plug into the formula. So this one's a piece of cake. So we're going to use, because we have side angle B and sides A and C, we're going to use this one. So we're going to take 1/2 AC times the sine of angle B, and in both of these cases it's the same situation, so in terms of labeling. So A is 62 whatever units, C is 20, sine of 130 degrees. So 0.5 times 60 times 20 times the sine of 130. So we get 460, whatever units they are. And then for tens, the same thing applies. You're going to have 1/2 105 times 64 times the sine of 72 degrees. So 0.5 times 105 times 64 times the sine of 72 degrees, and I get 3,195 units. So let me just double check those, let you know if I did those right. Okay, I just realized I plugged the wrong number in here, so if you plug in 62 instead of 60, you get 475. Otherwise, they're correct. Okay, now we've got two word problems. So here we have a plane that flies 500 kilometers with a bearing of 316 degrees from Naples to Elgin. So the question is, why is it 316 degrees based on that bearing? Because you've got this angle, which is 44. I'm just going by the picture in the book. Let me just pause for a second. Okay, so based on the drawing, I guess the way the bearing works is, in terms of degrees, you start at north. So north would be 0, and then you would go all the way around 316 degrees. Clockwise, and so then you'd have 44 more degrees to get to north. I guess that's because you have magnetic north, so that's probably why it's 0 is north, and why it's clockwise, I'm not sure, but this is the direction relative to north is 44 degrees here. This angle is 44. That's the thing you need to know. So it flies to here, then it flies 720 kilometers from Elgin to Canton. Find the bearing of the flight from Elgin to Canton. So using that same kind of logic, the bearing would be this angle. So in terms of a triangle, and it turns out that Canton and Naples are directly east-west, so you have this horizontal direction. So what we could do is we could create this triangle and deal with the angles associated with the triangle, and then we could back out the bearing information. So if this is 44 degrees and this is a right angle, then this angle interior to this triangle is going to be 90 minus 45, so that would be 50. So that angle is 56 degrees. Is that right? No, it's 46 degrees because it has to add up to 90 degrees. So this is 46 degrees. So 90 minus 44 is 46. Okay, so that's 46. And then we have the length of these two sides. Now if I can find this angle here, and also I know if I draw a horizontal line that this angle is 46 degrees because you got two parallel lines with a transversal. So this is 46, this is 90, and then if I add this angle, these three angles together, that'll give me the bearing for the flight from Elgin to Canton. So you kind of have to work this out based on doing a triangle. So let's call this side, this angle A. So this is side A. We'll call this side B. This is angle B. This would be angle C, and this would be side C. So we don't really need to know what side C is if we don't want to figure it out. We just need to figure out angle C. So I think the way this is going to work is we're going to find angle B using the law of sines, because we have side A and angle A. Side B, we should be able to find angle B. Once we have angle B, we can say the sum of the three angles equals 180, so we can find angle C. And once we have angle C, we can add these three together and get the bearing. So let's do that. So law of sines says the sine of A over the length A is the sine of B over the length B. And the thing we're trying to figure out is angle B. So we'd say the sine of B is equal to the sine of A times B over A. And so we get the sine of 46 degrees times B, which is 500 kilometers, divided by A, which is 720 kilometers. And you see the kilometers cancel out, so there's no units there. So we get the sine of 46 times 500 divided by 720. So the sine of B is 0.4995. Now that's approximately equal to 0.5. So we should get an angle pretty close to 30 degrees, I think, for angle B. But we'll just take the inverse sine. The inverse sine of 0.49995. And what I get is taking the inverse sine here. The inverse sine of 0.4995 is 29.97. So I'm going to say that's approximately equal to 30 degrees. Okay, so now we can say that angle C, I'll say measure of angle C is equal to 180 minus 46 minus 30. So we got 180 minus 46 minus 30. It's 104 degrees. So that's this angle between here and here, 104 degrees. So the actual bearing is going to be 90 degrees. That gets me to east to this horizontal line, plus 46. That gets me down to this line, and then I'm going to add another 104 degrees. So you got 90 plus 46 plus 104. So that's equal to 240 degrees. So I'm just thinking about it. Yeah, I think that's right. Let me just check the answer. Okay, so that's right. And the last one is this fire tower triangularization. So it says the bearings from the Pine Knob Fire. So this is the Pine Knob Fire Tower. So this is the tower over here, Pine Knob Fire Tower, to the tower of the Colt Station. So that's here. Is 63 degrees is north, 63 degrees, 65 degrees east. So what it's saying is that the angle between north and this line, this 30-kilometer line, is 65 degrees. The two towers are 30 kilometers apart, so that's fixed, and the angle's fixed. A fire spotter is spotted by rangers in each tower, and it has the bearings of north, 80 degrees east. So instead of going 65, you go to 80 degrees. So that's this angle, 80 degrees to this sighting to the fire. And here you go south, 70 degrees east. So that's the bearing here. So now we have this triangle, and we have to figure out what the distance is. We have to figure out what this distance is from the Pine Knob to here and from Coal Station to here. So what we can do is, you can see that this angle here is 80 minus 65, so it's 15 degrees. So that's the internal angle. Okay, now the question is, what the heck is, if this angle is 70, is there any way that I can tell what's going on? I think what you have to do is you have to extend this down to here. So this angle is 70 degrees. Let's call this distance, we'll call this distance A, call this distance B. So this is angle B. This would call this angle A, corresponds with that. And then we have this angle C, which is here. So that's angle C, this is side C. And so what I'm thinking, you kind of have to do this in two parts, possibly. So you could deal with this triangle first, and knowing this length and this angle, okay, so I'm going to pause for just a second because I want to think about this. Okay, I think I figured it out. What I'm going to do is create another triangle here. So what I'm going to have is a triangle, a right triangle like this. And what that will allow me to do is to figure out this angle. Once I know that angle in it, the rest of it's a piece of cake. Okay, so I've got this right triangle, and what I'm looking for this right triangle, I've got the angle is this, are these two here. So the blue angle is going to be 90, this is 90 degrees, minus 65. So 90 minus 65 is 25 degrees. So what I have is this right triangle with 25 degrees here, and the hypotenuse is 30, and so I should be able to figure out this. Well, actually, I don't even need to use the Pythagorean theorem or anything. So what I've got is, if this is 25 degrees and this is 90 degrees, then this unknown angle here, this X angle, which I labeled, has to be, so let's write this out. So what we have is 90 plus 25 is 115 degrees. And then if I subtract 180 minus 115, that's going to be equal to 65 degrees. So this angle here has to be 65 degrees. Okay, so now I can, let me just redraw the triangle that I'm going to analyze from now for this next part. Is I'm going to have this triangle. So this angle, this length is 30. This angle is 15 degrees. This angle here is the sum of these two, which is going to be 135 degrees. And now what I need to do is figure out A here. This is angle A. We'll call this angle C. This would be side C, and this angle here is angle B. So this is side B. So because I now know 3 out of the 4 angles here, I can figure out angle B. So angle B is going to be 180 minus 15 minus 135. So that's 150. Add these together, you get 150. 150 from 180 is 30 degrees. So this is 30 degrees, so that's angle B. And now I can use the law of sines. So I'm going to say the sine of A over A is equal to the sine of B over B. So that's, I know everything here except length A. So if I solve for A, it's going to be equal to the sine of A divided by the sine of B and times B here. So I have the sine of A, which is the sine of 15 degrees, divided by the sine of B, which is 30 degrees, times B, which is 30 kilometers. Now the sine of 15 over the sine of 30 is not 0.5, it's something else. It's probably close to 0.5, just because when the angles get, well, that's not true. Well, let's see how close it is. So that you get 0.517, so it is actually pretty close. So the sine of 15 divided by the sine of 30 is 0.517, not 0.5. Okay, multiply that by 30, and I get A is equal to 15.5 kilometers. And then you can also do the sine of A over A is equal to the sine of C over C. So I can solve for length C. That's going to be equal to the length A times the sine of angle C over the sine of angle A. So C is equal to 15.5 kilometers. That's what A is, times the sine of C, sine of 135 degrees, divided by the sine of A, which is 15 degrees. So 15.5 times the sine of 135 divided by the sine of 15, and I get 42.3 kilometers. So those are the two answers, 15.5 and 42.3. Let me check. Okay, so that's correct. So just kind of in review, what we did is we took the drawing in the book, and from the bearings, from these two angles, we were able to find this internal angle, 15 degrees. To find this angle here between the vertical, I created this right triangle, where this angle, the blue angle, was 90 minus 65, which is 35 degrees. And then I used 35 degrees with a hypotenuse of 30 kilometers. Well, I didn't actually use, I keep wanting to do that, but I didn't. I just said that if this were 25 degrees and this were 90 degrees, then this had to be 65 degrees. So then you could add these two together to get this angle, internal angle is 135 degrees. So at 15 degrees, 135 degrees, 30 kilometers. So I knew two interior angles, I could find a third interior angle. and then knowing all the angles on one side, and I can apply the law of sines twice to get the other two remaining sides. So that's what I did.